Hey there, guys. In this video, we're going to take a look at Unit 2 on function models and features. This is going to be kind of like an extension or just kind of adding one more thing on from what we were looking at in our last video with our domain and composite functions. Only one thing different. If you look at our chart, you notice that I've squeezed in exponential function between our quadratic and rational. There's going to be a couple questions that ask us to compare the value of linear, quadratic, and exponential. And whenever we're looking at those, quadratic equations are going to end up in the long run having a greater value than linear. And exponential functions are going to have a greater value than quadratic, which will also have a greater value than linear. And I've got a picture for you to show you what that looks like. And if you look, we have our line of y is equal to 2x. So this is our linear equation. And whenever we're looking at that value, the max value is going to keep increasing, but not as quickly as our quadratic equation is increasing. And neither of them are going to increase as quickly as our exponential function is going to be increasing. So that's kind of the only thing that this lesson really adds in. So let's start practicing with our problems. So taking a look at the first problem that they give us, it says select the correct answer. What is the domain of the function? So looking at that function that we have, we're still making that same decision that we were making in the last lesson. What type of a function do I have? So if we go and we look at the different types of equations that I've listed for you, we've got linear, quadratic, exponential, rational, and radical. So the one that we're looking at for this first example is going to be a rational function, and we're looking for where that denominator is not equal to 0. Okay, so if we go back and we look, we want to know where x squared minus 9 does not equal 0. So with this one, it's a squared, or it's a quadratic. So it's one that we need to factor one, or we can solve using any of our other methods that we have for solving our quadratic functions. I'm not going to factor it. I'm going to add 9 both sides and then do x squared is equal to 9. And then I want to get that squared by itself. So I'm going to take the square root of both sides. And don't forget, anytime we take the square root of a variable squared, we're going to end up with an answer that is plus or minus. So square root of 9 is 3. So x is going to be all real numbers that we could have except for 3 and negative 3. Because if we take those and substitute in for that x squared, our denominator will be equal to 0. And so that answer won't exist. All right, looking at the next one. What is the domain of the function f of x is equal to 2x plus 5? So again, make a decision of what type of a function this is using the chart that I've given you, and then use the chart to figure out which one of those it's going to be. Looking at 3. So these types of problems, they start mixing in word problems. So you have to figure out what type of a function it is, and then kind of think, well, is it reasonable for us to have all real numbers? Is it reasonable for us to have negative? Is it reasonable for us to have all of the positives? Is it reasonable for us to have all of the decimals in between? Because that's what real numbers are. They're everything negative, everything positive, and 0, and then all the little decimals and fractions in between. So if we're looking, they're selling a box of pencils for $10 a piece. And they're using the function f of b is equal to 10b, where b stands for our boxes of stands for the number of pencils. Sorry, b is going to stand for the number of pencils that we have. Sorry, number of boxes that we have. And it wants to know what is the domain of the function. So all positive integers and 0, all real numbers except 0, and all positive real numbers. So the first decision we kind of have to make, because if we look at these three answers, these three have real numbers and this has positive integers. So like I just talked about, real numbers are everything like whole numbers, decimals, all positive, all negative kind of a thing. But when we're looking, we need to kind of narrow it down. Are we talking about real numbers or are we talking about integers? Remember, integers are those numbers that you can list. So if we're talking about all of the integers, just by the definition, integers is going to be like -1, -2, -3, and then we're going to keep going on that way, and then 0, and then 1, 2, 3, and we're going to keep going on that way. So if we're looking at B is the number of boxes of pencils, and we're looking at our domain, so we're worried about how many boxes we can have. Can we have negative boxes for pencils? No, so that's why they're talking about all positive. So that's going to automatically eliminate those for us. But then it's going to talk about integers versus real numbers is now the difference that we have between these two problems. So remember, real numbers would have the decimals. So we would be talking about like 1/2. It would be talking about 1 3/4. So we've got to think, can we have half of a box that we are able to sell somebody? Can we have 1 3/4 of a box that we could sell somebody or that we would buy in a store? So you've got to figure out the answer to that question and then pick between either A or D. Looking at the next one, which function's domain consists of only real numbers greater than 3? So this is where that chart will come in handy. So you're going to want to go to the chart and then look, and we're looking for the domain. So here's my domain. And we want where the value is going to be greater than 3. So I'll give you a hint. We're looking at our radicals because we're looking for our value to be greater than a certain number. Whenever you start adding or subtracting things inside that radical, that is when you start moving things left and right, and this starts being greater than or equal to a certain number instead of 0. So if we're looking at this one, which domain consists of only real numbers greater than 3? Well, I just gave you a hint that we're going to be looking at our radical equations. So that means it's not going to be A, it's not going to be C. So between those two, which one would we set equal to 0, solve for, and then we would end up with x is greater than or equal to 3. Looking at the next one, in a bakery, the number of buns delivered is a function of the number of boxes packed. What is the domain of the function? So when we're looking at our domain is going to be talking about the number of boxes packed. So how many boxes, what kind of numbers can we pack? Again, we've got integers, positive real numbers, positive integers, and our rational numbers. So if we're looking at this one, like we talked about in the other problem, we can't do all of our positive real numbers because we're looking at, we wouldn't buy a fraction of a box. We wouldn't buy a decimal of a box. So then it's going to be between A and C. Is it only going to be integers? Remember, integers goes from positive to negative. Can we have negative boxes? And then C, the domain only includes positive integers and 0. So remember what we talked about before, and then use that to help pick. Looking at 6, the daily expenses for each of a transportation service company's trucks is given by this function. So looking at this, I'm already seeing this is our function that we're working with. So we're working with something that is linear. And then where d of x is the daily expense per truck and x is the daily mileage. And I'm focusing on x because we're looking at domain. It says identify the domain. Our domain is always going to be our x values or whatever that variable is that they have us focusing on. So they want the input for the function or our x value to be one of these things. Is it going to be all the fractions? Is it going to be all of the integers? Is it going to be all of the real numbers, or is it going to be all of the positive real numbers? Remember this, we're looking at mileage. Can mileage only be fractions, which is that first one? Is it only going to be all integers? Are we going to have like -3, -2, -1, 0, 1, 2, 3? Is it just going to be all of the numbers, both positive, negatives, and all the decimals in between? Is it going to be all positive real numbers? So positive real numbers would be like 0.5, 1, 1.75, those kinds of things. Is that how you would measure mileage? Looking at the next one, the distance in mile traveled by a cyclist given by d of t, where it's equal to 5t, where time is t in seconds. The domain of the function includes. So you've got to think about, we're talking about domain. Domain is going to be our time in seconds. How can we measure or count that time in seconds? Looking at the options that they give us, is it going to be all real numbers that are perfect squares? So for that one, are we looking at things like 2, 4, 9, 16, 25? Is that the only way that we could measure time? And then the next one is all positive real numbers and 0. So this is the, can we measure time in 0? And I'm just making up numbers, 0.75, 1, 1.25, and then keep going. Could we measure time that way? And then all real numbers other than 5, or all real numbers? So it's really, So it's really going to come between all positive real numbers and 0, or all real numbers, and you just got to think about how can you measure time. Okay, looking at the next question. These are drag and drops. So this is what I was talking to you about earlier. Whenever we're looking at these functions that we have here, which ones have a greater value, that's what these are asking you for. So arrange the functions in descending order. And you've got to be careful, because you could end up with a question that says descending and one that ends up with ascending. So you've got to be really careful which one it's asking for. So descending is going to be biggest to smallest. So you're going to want to start over on the left side of our chart that I gave you here. You're going to want to start over here. If it's asking biggest to smallest, we're going to want to start over here on the exponential. So I'm going to go, I've actually got an example lined up for you, but it's going to be in a different order. So these are going to be in ascending order. So this is going to be smallest to largest. So when we're looking smallest to largest, we're going to be looking at our table, and we're going to want to start with all of our linear things, all of our things that start with y is equal to mx plus b, or f of x is equal to mx plus b. So if we take a look, I'm going to want to find all of my equations that are aligned. So if I look, 2x plus 5 is a line, and then 2x is a line. So from those, I'm then going to have to decide between the two which one is, we're looking for smallest first, so which one's the smallest. The 2x is going to be smaller than the 2x plus 5. And then next in our list, if we look from linear, next comes quadratic. So I'm looking for things with, quadratic is like our x squareds. I'm looking for things that have x squareds in them. So here's an x squared, and there's an x squared. So those are what comes next. Between those two, this x squared is smaller than the one that has the x squared plus 2. And then lastly, the larger functions, or the functions that end up having the larger value in the long run, are going to be our exponential. And they are going to be the things that have a number to the x power. Anytime you have x in as an exponent, that is going to be an exponential function. So then looking at the two that we have left, we've got 2 to the x plus 3 and 2 to the x plus 10. So both of those are exponential. We have to just make a decision of which one's bigger. So the 2 to the x's both have the same value, but adding 3 adds a smaller value than adding 10. So plus 3 is smaller than plus 10. So that's how those types of problems work. So with this one, you're going to do the same exact thing, except you're going to be looking for your biggest function. So you're going to be looking to start with your exponential and find the value of that exponential that is the biggest. So you would want to start with this one, you would want to start with plus 10 and then do plus 3 next if you were looking for biggest to smallest. All right, looking at 9. 9 is going to be the same exact thing, except they've switched up the vocabulary and they're looking for ascending order instead. So this is the smallest to largest that I was telling you about. And then looking at 10. With these, they want you to match the functions to their domains. So you're going to use the chart to match the things up. So when we're looking for all positive real numbers, including 0, if we go back, all real numbers or all of these all of the options that we have right here, we have to just figure out which one it matches with what we've been given. So do we have linear, quadratic, or exponential that we're looking at there? So all I see is option, and I'll give you a hint that it's linear is what goes there. So all real numbers except 2. So going back and looking at our graph, we're looking for all real numbers except a certain numbers. Well, those are our rational type numbers. So looking at these problems, for this one, you're going to want to find your rational function and match it up to that. So I'm going to switch this hint that I gave you right here because I made a mistake. When we're looking at all positive, I missed the positive part. We're looking at all positive real numbers. So we can't have the negative ones. So I was wrong. We can't look at all real numbers. We're just looking at where they are positive. Another way to say that they are positive is that they are going to be greater than or equal to 0. So this one is actually going to be a radical. So it's going to have a square root in it. And then that all real numbers is going to be linear. And then the last one, all real numbers greater than 2. So this is another one where we're looking at a radical. And the big difference is it's going to be greater than 2. So you need to figure out which radical equation that we have up there has to be greater than 2. Okay, well, I hope this walks you through your mastery test for the function models and features. If you need any help or have extra questions, make sure to email Ms. Schaefer or I, or join us during our live office hours from 1:30 to 3. All right, guys, see you next time.